So in this video, we're going to recap and do a deep dive into how we got the SERV processor to run a Blinky program on the microchip PolarFire SoC that's sitting on the Beagle V-Fire. We'll look at some of the Verilog code. We'll run some simulations with Icarus Verilog. So let's get going. All right, first place you start is over on openbeagle.org. Go to my account, Busted Wing One. Gateware. Go drop down into the Gateware serve on fire. And if you want to follow along, then you'd probably want to do a fork. I can't fork my own process, but you just fork on it. It's a few simple questions. And then you've got a fork that's dumped into your work area. Let's see. If the fork fails, you probably need to be granted access to create repos on this server. That's simple to do. Just pop on over to the forum, the BeagleBone forum. You can pop down to here, help, support. That'll get you there. And just ask for access to fork. And someone will help you out. All right. So anyway, so once you've created your fork, you'll be sitting in your area. You go to your code, you go to here, you get a code, and you click on your clone, and you do a Control C of that. Or this is what I do at least. And then I go over to my virtual box. So I'm running in a virtual box on my Windows machine, and I'm running Ubuntu 22.04 on it. And then you're here, and you do type in git clone, paste. You got that there. And this should give me an error because it already exists. So let's call it ABCD. We'll delete Gateware. Gateware ABCD. We'll delete that in a moment. Gateware. Who cares? Yeah, I bet it'll burn me. Gateware. ABCD. And then it clones. It doesn't take very long at all to do. And you're there. And then you can hop down into your Gateware ABCD. And then there you have it. And now the next thing you want to do is you want to get, well, maybe you don't want to do it. So the next thing we're going to do is we're going to get the SERV repo, and we're going to take a look at that. That's probably going to be like around 5 minutes worth of talk. If you're not interested in doing that, because you don't need to be, go get a coffee. So here we are. So let's go to here. So so the official SERV repo is here under Olaf K on GitHub. There's a lot of steps to bring it up. You can go through the steps. I did. It's probably worth it to try to understand what's going on under the hood. But I created a script over here in my area, Busted Wing 1 on GitHub, called Serve Auto Setup. And that kind of has a script there. It takes care of all those steps. So that's the way I kind of recommend doing it. So Control C, get out of here. I'm here at the top level. I'd get clone, Control paste, return, and that's done. Not bad, huh? Now then, we're in this little area here, and so we want to serve auto setup, which is what we just cloned. You're here, you drop down. Then all you have to do is run, well, actually you have to source it. So source or dot, just stay with source. Serve create.sh, and so this will create a work area and do all of these steps, which you could do manually if you're so inclined. It creates some Verilog, it creates some Verilator aliases. Let's see what happens here. So Verilator Phil. Let's do that one. Verilator. Phil. I think that's the philosopher. And let's see. So now, right now, it's compiling. It's not too bad. It doesn't take too long. It's kind of fun to do. It's running, and now you got these philosophers holding one fork, thinking, eating, starving, doing whatever a philosopher might be inclined to do. So that's running a simulation of the SERV processor doing this program, and the SERV processor spitting it out across the simulated serial port, and there it is. Not bad. It's kind of fun. Control C to stop it. Clear. So there was a bunch of aliases there that you could probably run if you want to. If you don't, that's okay. Now then, so where do we hide the good stuff? So after you've run one of those guys, you got this build routine here. Well, there's two places that things are hidden. The originals are hidden in this Fuse SOC libraries. And you can do ls fuse SOC libraries and just dump down into serve. And then you've got a bunch of guys like Servant and Servile. And I think there should be just a serve somewhere. I think there's a serve. There's serve. Serve. So it's hidden in RTL. So we got all those files hidden in there. So let's take a quick look at one. RTL. So you got all those files in there. Servant, Servile. Let's see. Oops. Servile. You got a few Serviles, which is really a wrapper around the Serv core CPU. It's a very small wrapper. And then you got Servant. You got a lot of files in there, and that's really a wrapper around Servile. So we got some wrappers around wrappers. And so you need all that to simulate. So this is all over in this serve workspace. And well, you can leave it over here, I guess. But what I did was I copied it over to the Beagle vFire's sources tree, and so yeah, so you can do it either way. But I've already copied it, so I'd probably recommend just using what I've copied over. Um, and so now let's. I think that's the segue into serve processor is over, and we're getting back into Beagle v Fireland again. So here we are. This is the Gateware that we cloned. You got the sources directory here, so we want to cd down into sources slash FPGA design, script support, components, not HDL. That's a tricky one. And then cape, and here we are. And now then, we got these guys here, bunch of choices here, and we want to go into, so when I first started out, I started out following the user guide, which is excellent on the Beagle Bonefire um, site, and just to get it so that none of this is magical for you here. Let's see, open Chrome, boom. See, I keep this Beagle. Nope, I don't want Beagle born. I want Beagle vFire documentation. So you come up in here, right? So this is like their Beagle vFire. We could start up here, right? And then you drop down to Beagle vFire. And then you drop down into demos. Then you drop down into customize Beagle vFire. Keep Gateware using Verilog. And this is a great document. Read it. Definitely read it. It's good. Basically, the very first time I followed this to create my area, and yeah. So anyway, so one of those first steps was copying like this Verilog tutorial into my serve cape, and so now all my goodies are in my serve cape. All right, so we got this here, and we've got Let's see. We've got, if we do a find of HDL, this will show us all the HDL files. You got all these SERV files, which I've copied over from that SERV area. So now it's in the nice HDL area with all the other good guys of like IO pads and the cape.v and other goodies. And and now we've got just quick drop is let's go into serve sim. All right. Oops. Serve sim. Okay, VWD. So here we are. And so what I got here, it's a pretty simple test environment. It's got a couple of scripts in it. It's in the scripts folder here. But while we're sitting up here, not in the scripts folder, but one level up from it, what we'll do is .scripts compile iverilog. And boom, that's it. There it goes, compiled successful. And then what we want to do is sim iverilog. Right? Oh. And so what this is doing is showing right here. The first thing is I'm loading the serve memory. So I'm simulating that I'm loading the serve memory from, like, say, the MSS, one of Polar Fire's high-powered RISC processors. So I'm emulating that I'm writing into it, like over the APB bus. Then I read it back to make sure it got in there okay. I print some passes just for good measure. And then like you can see the Q is starting to go, and that's the blinky bit that's going low and high and low and high and low and high. All right, so that's how you do it. You could take a look if you're interested into the scripts folder for how I'm doing those scripts. Very simple, extremely. It couldn't be any simpler. Um, and let's see, yeah, and also what do we want to do? Oh, so right now let's take a look at the waves. So this is kind of fun. GTK wave test.vcd. So that's like, I think that stands for Verilog change something dump. I think dump. Um, and so here we go. Let's maximize this guy here. So you saw I started this, right? Yeah, I think you did. File. All right, so here we go. So we got this test bench. That's the top level here. That's what I called it. We got a couple of tasks that we maybe take a quick brief look at, but I will blast over it. Then we got this DUT, and then the RAM is where so I did work here on, which is really Servant, which is the wrapper around the core, CPU core. And then I did a little bit of work in here. And so the things of interest would be like here, I'm popping in. Let's grab some of these signals. What the heck? Do a Control A, grab them all, bring them on over. Now, this is all red, and too much red, but it's also going up to 7 picoseconds because it's not showing much of the simulation. The simulation ran for microseconds, maybe milliseconds, I don't know. So let's click on this little checkbox here for zoom fit, and that works the first time at least. And now you got a lot more greenish type of stuff. Um, Probably one other worthwhile to get. Let's go up one level. Let's go to here for Q, and let's add this guy down here. And you can see that the Q is bouncing, which shows that the simulation is working, and that's what we really only want. If you zoom in here a little bit more, we've got it. We're right in this enable, where you can see this P enables, and the read data is here, and that is where we are writing and then reading it back into that memory. Kind of set it up so that this select line, whenever the serve core is in reset, like we can write to this guy. When he's not in reset, he's running, and then the serve core has access to it. We'll show you that in the RTL in the Verilog in just a moment. All right, so that's this guy. So I think that's about all we really need to have. We have videos on how to use GTK waves in in detail if you're interested. Control Z, BG, that's there. Now then, let's do a cat of RTL file list. So these are all the files. Most of these I did not change. The only two I added was LED, APB Servant, and APB Servant RAM. What we did was we added an APB bus interface. We've talked about this interface before. Straightforward interface. It's got an address, a write data bus, a read data bus, a write strobe, a select, and enable. The error ready and error are not used in the cape, so you can ignore those. Let's see. Here we've got it where a cell is set to the reset that goes into it. You'll see the game that we're playing with reset in a moment. So when the cell is high, then we're using the APB side. When the cell is low, then we're using the wishbone side, which goes to the CPU. And these addresses here go to, this is what's called an inferred memory, an inferred single port memory, where when the write is asserted, which is this guy, when the write is asserted, then whatever's on the write data bus gets put into the address, to the memory at the address defined by matter, which is right here. Yeah, that's really all that we did. Yeah, then let's take a look at the other Savant. It's even easier. All we did was we connected up the P enables, ABB bus enables. So we brought those out to the top, so that's going to get essentially to the cape.v. And then you can follow P enable, and you can see it gets down to the RAM here, which is where we added the P enables here. That's about it. That's it, in fact. If you just scroll down a little bit further, so you can see Servant has a timer in it. Servant's got a little bit of GPIO action where a Q comes out. It's got a register file, RAM. Then it's got Servile, which is really a wrapper around the CPU. The SERV, so Servile instantiates the SERV processor, which is the CPU. And that's all that's in this top level file. All right, so let's close out on this guy. We've looked at the RTL, we've looked at the add. So after you've made all the changes to your any modifications that you make, then you do like a git status. Right? I always do a git status, and we don't have any changes here. Let's go back up to the top. All right, and then. Yeah, I don't know. Let's do a demo of so let's edit the README. Put in let's see. Serve APB serve. There we go. Why not? Control S, Control Q. Get out of that. All right, now git status. All right, and then all you have to do is do a git push. Oh, oh actually, I'm sorry. Git git add readme. Git commit dash m little message bump readme. All right, and now we can do a git push. Now, so when you do this git push, it pushes up to the GitLab repo that's running on the Open Beagle servers. And the Open Beagle servers are then going to run this CI continuous integration script. So it'll automatically run and kick off a build, which is kind of cool. And so it'll build and we can watch it build. And when it's done, then we can load it onto the onto the Beagle vFire. So right there, look at that. That's it. So now let's take a look. Let's go pop back over to the um, let's see. right here, right? Now what you do is you go over to build. You can slide over if it shows up, pipelines. If it doesn't show up, you can click on build and you get pipelines this way. And either way, click on pipelines as a left click. And look, so you get it running. So you can see all my past passes and also my embarrassing fails. I got more passes than fails. I must have rigged it. So anyway, it runs for like around 6 or 7 minutes. And when it's done, what you can do is you can download the artifacts. So I used to download it to my PC. So just by clicking download, right? You can just click on download job archive right here, right this one. And so you can see it pop up here. And it did the downloads, it finished the downloads, and then I would unpack it over there. I don't do that anymore. I go and I click on this guy, and I right click on archive, and I copy the link address. All right, and then let's see, I don't have it powered up. Let's get it powered up as I'm babbling here. Maybe it'll be fast enough. I don't think it will be. Um, and So I'm powering up the Beagle V Fire now. It takes around a minute or so to get active. Um, so I guess while it's powering up, we can do some talk about that. So we've done a cut and paste here. We'll maybe get that one because it'll probably take so long. Um, let's see. So go into search, and what do we do? Device manager. So let's take a look on device manager. Um, and let's see if we got there in time. Okay, it hasn't happened yet, so it's still booting, but eventually, right there. So it comes up and it says COM19. So that's how you know what COM port that you want to connect onto the USB. And you don't necessarily need that, but it's nice to have. And so let's go PuTTY and pop up over to PuTTY, open it up, and click on the serial button there. Sets it up nicely here. We'll change the speed to 115, 200. Someday I'll play around with other speeds, see how fast we can go. And click on open, gets you to PuTTY. So even without logging in, it gives you the information that we're looking for. So right here, that 172.16.07, on my network, that's where my Beagle V Fire is. On your network, it'll be different, right? So we don't need to log into here. Just leave that there for fun, right? And so now let's go back and let's go and let's create a new tab. And let's see, SSH Beagle. Our username over there is Beagle. And you know that because going back to PuTTY, it says that the username is Beagle and this here is your password. So there's two important things that I give you right in this little screen here. Your username, your password, and 117.16 and your IP address. 172.16.07. 172.16.0.7. Did I get it right? We'll see. I didn't find it. It's because I didn't get it right. Let's just go back to this. 172.16.0.7. Oh, yeah, I got it right. I just typed in the wrong thing here. So we got this little look. It's kind of like an email. You put an at there and hit a return. And now then, so it's loading. Beagle is logging in, and we saw the tab. It gives you the password right here. They're not shy about that password. um, and boom, you logged in. And now then, what I do now is let's see, RF custom design. I'm getting rid of the old one that I did. Right, just let's here. All right, and so now get rid of that guy too. All right. All right. And so let's go back to here. This guy's still going. So let's take this one that I did just before this video. It's probably fine. And right click on Build Job Archive. Copy link address. And go back over to here. This is again running in my Ubuntu 2204 VirtualBox. And wget and left click, right click, paste. And let's see if it returned. So that's pulling all this stuff down. So that pulled down all the artifacts that we're interested in. I don't really like that. So I put it into this file here, which I guess lines up with that file. So I guess I got what I deserved. So I think there's a dash, capital O. So it is capital O, capital O, archive dot zip. It returned. Let's see. Do an ls, and there it is, archive dot zip. And so now we can do an unzip of archive dot zip. And again, we are running right now on the Beagle V Fire. Isn't that kind of cool? And so now then what we want to do is there's a script. What's it called? Change something. Change Gateware. I don't never remember. So let's do a find. Let's see, a sudo. We're looking places where we find sudo slash the tippity top find slash grep something with a change underscore gateware. I think this might be enough though. Look at that. All right, so that's where they hit it. All right, so what we have to do is we have to run this program right here we just found, and by just remembering the word change, and then we have to go down and this guy here. So the My Custom FPGA design. So you got these bit streams and then the My Custom FPGA design. All right. You hit a return. Must be root. Fine. So go over sudo space. And I get to the beginning of the line with a control A, if that's new to anybody. And so now it's building. It's going to take around a minute or two to build. Is there anything I can babble about while it's running? I think I've said enough. I'm going to shut it down for now and start up after it restarts. Okay, so we were just building, and also for your information, our bump README, the one that we just did together, it passed. So we could still go down and click him, left click on that, right click on archive, copy link address, and do what we just did. We won't do that. So now that we go back to our again our VirtualBox, our Ubuntu VirtualBox, and you can see that the connection closed. So all you have to do is probably an up arrow. You got the SSH waiting for you right there. Hit an enter. Enter your password, which it's telling you again right there. And that's logging us in. And here we are. So now we're running again on the Beagle V Fire. ls, and so we've rebooted. We've got one blinky going, one blinky, which is what we expect because the one blinky is from our hardware Verilog blinky experiment. Um, so now we want to turn on the risks. I mean the serves blinky, and so wrote a little ditty of a program. We'll take a minute, look at it in a moment. And where do I hide it? Run serve, cat, run serve. So this is this program here. And yeah, we'll take a look in a moment. Let's get some action going. So all you have to do is GCC. You only have to do this one time, so it's not like every time you reboot or reload, you have to do that. This is just the like once you've compiled this one time, that's all you need to do. GCC run serve .c -o run serve. So simple as you can get for a GCC command, right? And there it is. And now you can run your .serve. Of course, it'll fail on me right now. Run serve, and boom, and it wants me to have blinky hex. So this blinky is the hex program. Again, it's failed because you got to be sudoed. So while we're here, let's do a cat of blinky .hex. So this format may be familiar to some people. This is the format for a readmem h command in Verilog. And so that's what this file format is. It's very simple. And so run serve runs that. And we got a sudo whenever you want to use these commands. And then again, and boom, look at this. So if we look through what's been printed here, the serve base is at 4104. So the serve should have started out at reset when this program was going. And this comes back and says, yep, it was. Then we go into this phase where we're reading the blinky.hex file and we're writing these values to these indexes from mem 0 to, there's only, I guess, 11 values to 10. We immediately read them back, make sure that it matches. That's all good. Then after it's all been done, let's read them back again just to make sure they're truly there. So then we're doing these reads and we're making sure that these match these, which they ended up doing. So that's all nice. And then we take the serve out of reset, and then the serve should not be in reset, and it is not. So that's a pass. That's good. So, and then we're saying that we're now running. So I should be able to look and see two blinkies now. I'm seeing two blinkies. Trust me, or run it on your own. Run it on your own Beagle V Fire. Yeah. So that is that. I think probably we want to do a quick look at cat of what do we call it? Run serve.c. Let's do a quick look at this guy. All right, so most of this is just boring drivel. You know, you got your includes and some defines, nothing actually important there. So the tricky part I've not got that didn't know about and that I've learned on this is that we run a little setup program here, which goes and you tell it the base and you tell it how big of a block you want to set up for it, you know, like 4K or 64K or whatever. And then that returns essentially something that I'm thinking is like a virtual address that maps to this physical address. I don't know if that's a good way of thinking about it, but that's the model I have in my head at the moment. And so I created one for the CSR and one for the serve. And then what I'm doing is like for the CSR, like I connect it up and we'll see this in the cape.v. I guess I glossed over cape.v. We'll have to get back to him. So the first So on address 10, they had their CSR, and I'm using that to set and turn on and off the reset, which enables and disables the serve processor. And so we've got that address. That's yeah, you can follow along with most of this. The important part that we've all got to get is that in this routine, we've got this mmap, which essentially you open up a file, because I guess everything's a file in Linux. You get this file descriptor, you pop that file descriptor here, your hardware base, and the number of bytes. And so this is like the 4104.000.000, and this is the number of bytes, and then that returns back this base address, which then gets returned from the function. So I'm sure someone can explain it better than I did, but this is the magic line that you want to play with. Yeah. Oh yeah. So one thing, so two things I noted was we didn't look at Cape, and we did not look at we did not show how to SCP file over. So here we go. Well, so So say you wanted to get a program over to the Beagle, and so all my software is stored in this no. All right, well, we're way down here. So cd ls cd hdl ls. Take a look at first. So here we are. I'm going to take a look at Cape, which I should have done before. Cape right here, Cape, Control F, APB, something, serve. Give that a shot. Okay, and so here's this little section where I'm doing it, where I'm instantiating right here the APB servant. And so this is the module name. This is the instance name. These are some parameters that I set up with the defaults that seem to work. I'm sure other values will work better. And these are where we are instantiating, where we got the clock and reset coming in. Note that this reset here I call serve reset is coming from the control status block, which was in the very original design. So I'm taking advantage of that. So it comes out as bit 0, it's serve enable, and then I invert it to make it serve reset. And yeah, and this is the blink that gets wired over to the I/O pin. You want to find it? Sure. All right, so we navigated around. Here's these little registers here. When we pop Blink onto this, Blink 2 is the one that's coming off of my Verilog version. So I think I showed you what I needed to show you here. Control Q. Now then, CD tilde slash git slash oops tilde slash git slash gate where serve. Okay. All right. And then, so all the software that I've got is stored down in a folder called software. And so right here is read serve C. And if you want to get it over to the Blinky, you would just copy it over there. So it'd be an SCP, read serve C. In my case, 172.16.0.7. Probably I put in Beagle add forever, right? Beagle add. And then hit a colon after that for SCP. All right, and then so that's how you'd SCP any of the software programs from our repo over to the Fire. I think that is it. Hopefully it's enough so that, well, at least I can remember what I did then from it. I think that's all. Bye.